Hello everybody, and welcome back to another GIS statistics lecture video. And in this video, I want to go through a sort of calculated example of this inverse distance weighted, right? IDW, inverse distance weighted. And what I want to do is I want to focus on this point right here. This is our unknown point. And we have 5 points distributed around it. The letter is the point identifier so that we can keep track of them. And then the number is the value, right? So this would be that Z that we keep talking about. We want to calculate, okay, well, what is the value for this unknown point? So what I've done to save us a little bit of time here is I've gone ahead and I've already calculated the distance between the point and the unknown point. So this value right here between A, which is this point here, and our unknown, right, this distance right here is 1.14 units, right, and so on and so forth. So what we can do here is we can start to walk through how we would calculate IDW. And what I'm going to do here, because there is a lot of math, I'm going to do an example for part, and I'm going to give you the values, and I'm going to do an example and give you the values. That way we're not constantly having to do all of the division and everything and just filling up an entire blackboard with numbers. So the first thing that we need to do is we need to sort of recap what IDW is, right? So IDW for this unknown point, right? I'm going to call this U, Z sub U, right? The Z value for this U is going to be equal to the sum of the weights for the ith point times the Z value, right? That's this thing, it's this part here, divided by the sum of the weights. And we said last time, right, we said previously that the weights, right, the weight was equal to 1 over the distance between U and I to some power we called alpha. And I'm going to do an alpha equals 1. Actually, that's a good point. I'm going to do alpha equals 1 in this example, which is one of the standard values. So let's go ahead and let's calculate this top part here, this Wi times Zi for A, and then I'll give you the values for B through E, and then we can do the summation. So Wi, in this case, let's calculate Wi for point A. So Wi for point A, so we'll call this Wa, is going to be 1 over the distance between U and I. So U in this case is the unknown point, and I in this case is A. So this distance here is going to be this distance here, which we already said is this distance here, right? This distance is the distance between the unknown point and A. So this is going to be 1 over 1.414 dot, dot, dot. And if you do the math on that, you get a value of approximately 0.707, right? So we could put Wi, we could put 0.707 there. The next thing we need to do is we need to multiply Wi by Zi. So this is going to be Wi Zi is the next thing that we're going to put here. So Wi, Wa, Za, right, this is going to be equal to Wa, which we calculated as 0.707 times Za, which is the value of that point. And the value of that point in this case is going to be this 5 here. So we're going to pull that 5 down to there. All right, so if we do that, right, 0.707 times 5 is going to give you a value of approximately 3.54. Right, so our Wi-Zi is going to be 3.54. Okay? Let's go through one more, actually, just to make sure that we kind of get where everything's coming from. Let's do WB. WB, right? Again, we're having 1 over the distance to some alpha. And again, in this case, our alpha is going to be 1, so we're not actually doing anything with this alpha in this case. So what's the distance between U and, in this case, B, right? Our I is B. Well, the distance between our unknown point and here is going to be this 1 right here. So this 1 is going to come here. So in this case, right, our WB is just going to be 1. Right, our weight for this point is just going to be 1. Well, what about the weight times ZI? So what is our WB ZB, right? That's this part here, WIZI. In this case, I is B. So what is WB ZB? Well, that's going to be our value times our weight. So that's going to be 8 times 1, which is going to be simply 8. So our WIZI for point B is going to be 8. Again, it's the weight times the value. So hopefully that makes sense. So what I'm going to do now is I'm going to actually speed things up, and I'm just going to write down what you would get if you did the rest of these. So if you want extra practice, I would encourage you to pause the video and calculate these 2 columns yourself. I'm just going to write down the answers. So this is going to be approximately 0.447. This is going to be approximately 0.707. And this is going to be approximately 0.235. So once we've figured out the weights, we need to go back in and figure out the weights times the values. And again, right, to reiterate, that's just this value times this weight, this value times this weight, and so on and so forth. So I'm just going to quickly fill in that column. Right, and what I want to do is I want to take a quick second here and examine this weighted Z column, which is what this column is. And I want to look at the difference between what happened to this value 8 when the distance was 1 compared to this value 24 when the distance was 4 1/4. Right, look how much more drastic that reduction is. Right, when the distance was 1, right, it didn't really change that much. When the distance was 4 1/4, right, this got reduced by a significant margin. That's the point of this inverse distance weighting, is that the farther the point is away, right, the less contribution this high value is going to have to the overall value. All right, so we've calculated the WI, WZ. We've calculated all the WIs. Now I have to sum these things up. So we're just going to add these 2 columns, right, the sum of the weights. If you add this up, roughly 3.09. If you sum this column up, roughly you're going to get 29.25. Now I know if you're doing the math at home, I might be off by like a decimal place here, like this may be 3.08. Again, I'm just sort of rounding everything as I go. So if we do that, right, so now we have this right here. Actually, let's do this really quick. This right here, this sum WIZI, right, that's this value right here. Right, this sum WI, right, that's this value right here. ZI is this column, WI is this column. Hopefully you're with me so far. The last thing we need to do is we need to then take and divide this number by this number. right? The sum of WZI divided by the sum of the weights. And if you do that, you're going to get approximately 9.45, right? So to sort of put that over here, right, the unknown value is going to be approximately 9.45. Now, does that make sense? Let's just think about it, right? Because it's always a good idea to think about what we're saying. Well, we have a point over here with 8. That's kind of close to 9. We have a point over here that's 5. That's quite a bit lower than 9. We also have this point 12 here, right? That's a lot higher than this. And then even though this is a low value, it does contribute a little bit. So it does make sense conceptually, right? That 9.45 would be in between a point that's 8 and a point that's 12. So this answer does sort of pass our gut check. Hopefully this made sense. I know it was a lot of math. Again, if you're confused about where anything came from, I encourage you to pause the video. I encourage you to look at the diagrams, rewatch any parts you're confused about. And as always, please reach out. Thank you.